Alright, thank you for joining us. In our video, we'll be looking on to bearing question. There are a few exams coming up. Some of my students had asked to look on this question. So for the first question, it says a plane carrying tourists leaves island A on a bearing of 0.73 degrees for 33 kilometers and flies to island B. It then flies to island C on a bearing of 163 degrees and 44 kilometers from island B. Calculate the size of angle ABC, the distance from angle A to C, and the bearing of C from B. Second part of the second question now asks us the diagram not drawn to scale shows the journey of a ship which sailed from port A to port B and then port C. Port B is located 32 kilometers due west of port A, and port C is 45 kilometers from port B on a bearing of 0.40 degrees. Calculate, given your answer to three significant figures, the distance AC and the bearing of port C from A. The next part of the question I will look on, it says the line segment BC passes through the point A, -5 and 3, and has a gradient of 2/5. Express the equation of the line BC in the form of y = mx plus c. I want to show that BC is parallel to this line, 2x minus 5y = 1. And to top that off, we're going to look on this function question that says 2x minus 1 divided by x plus 3 and g of x 4x minus 5. We're going to determine g of 3 and f of g of 2 and f inverse x. Alright, so to look on the first question, which is a bearing question, there are some key things that we need to know. That bearing is a measure of 2 points starting from north, right? And we know we can east, south, and west, right? So it is measured by using 3 digits, so we can have 0, 0, 0, or 360, 0, 90, 180, and 270 degrees, right? So we always start measuring from our north, and we use 3 digits to measure it, and that bearing is a measure of 2 points, given that we know the angle, right? Alright. We're gonna look on the first questions now, and another important thing that we need to know is, given you have 2 parallel lines and you draw an intersection, what that will create is that will create an alternative angles. So let's look on this side right here, and this side. This angle, this angle. Alright, so what we're saying is that an alternative angle which forms a Z, right? What we're saying, considering this angle right here and this angle right here, both those two are alternative angles which are the same, right? Additionally, for the complementary angles now, given we know this angle here and this angles on a straight line add up to 180 degrees, and if we have an alternative angles, right, we know that it would consist of either 3 angles or 2 angles that would find and add up to 180 degrees, right? So for the alternative part, it is where the angle that form the Z are equal, and the corresponding angles, which are the complementary angles, they add up to 180 degrees. With that said now, in drawing our question, number 1 says plane carrying torus leaves island A on a bearing of 73 degrees, right? We start from north, in which in measuring our bearing, we always start from north, right? And this would be our point A. Going this straight line would give us a 90 degree, but the question said he's traveled 0, 73 degrees. So an estimate will be right here, 0, 73 degrees, right? From our north and our point A, it then traveled 0, 73 degrees. And it goes to point B. So it said from B now, it traveled 163 degrees. So we're going to take our bearing still from north. You know, going this straight line here, that would give us a 180 degree, but then it traveled 163 degrees. So from north to right here, 163 degrees, right? Then it traveled to island C. Alright. So we are now to calculate the angle ABC. As when we were doing the alternative angles, we can see a Z forming right here. Alright, so we know that from our north, we know this angle is 0, 73 degrees, or we can say this angle is also 0, 73 degrees. Alright, so now this is a 73 degrees. See that from our point B to our point C, it traveled 163 degrees. What we can do is to say 180 minus 163 degrees, that gives us 17 degrees. Additionally, see that we had known that this straight line is a 90 degree, we can say 90 minus 0, 73 degrees, that would equal a 17 degrees as well. So we can look at this small portion we had gotten at 73 degree right here. We can add so angle ABC would be equal to the 73 plus the 17, and that is equal to 90 degrees, right? Which would be the small portion right there. But now that we identify that this angle ABC is equal to 90 degrees, we can now look at our second question. How we identify that? We first realize that angle from our north to this point right here at B, it forms an alternative angles. Alright, we see this Z. So this small portion here would also be equal to 73 degrees. We know this section here would be a straight line, so we subtracted 180 from 163, and we got 17. Adding the 17 plus the 73, and that would equal to a 90 degrees. Right, so we're able to find that answer. The next part of the question now, it asks us to find the distance from island A to island C. So we want us to find this distance right here. Right? So the distance from A to B is 33 kilometers. And distance from B to C is 44 kilometers. Right? So from A 73 degrees and travel to B for 33 kilometers. From B to C, the plane traveled 44 kilometers. Alright, so we need to find this unknown distance right here. Seeing that we identified that this shape, or this angle right here is a 90 degree, we know two sides, right, which would make the right angle triangle. We can now find this distance AC, which would be our hypotenuse. Then applying Pythagoras Theorem that says C squared is equal to A squared plus B squared. And we're trying to find this hypotenuse, which is considered our C. We can now apply Pythagoras Theorem formula. We know two legs, and we're trying to find the hypotenuse. Calling this side A, we can say 33 square plus 44 square. And 33 square give us 2025, and 44 square will give us, I know, 33 square will give us 1089. 1089, and 44 square will give us 1936. Alright, and adding these two figures, we now know that our c squared is equal to 3025. And in order to find c, we need to square both sides. So we're going to say square root of c squared, square root of 3025. So our c will be equal to a 55 kilometers. Alright, so this distance is equal to 55 kilometers. Alright, so the next part of the question asks us to find bearing of C from A. So we're trying to find bearing of C from A. So all this angle right here, we're trying to find it to get to C. From our north to get to point C. Alright. So we will have to use the trig ratios, seeing that we know what are the two sides that we know. We know our opposite and we know our adjacent. So in just identifying our trig ratios, sine opposite over hypotenuse, no, cos adjacent over hypotenuse, tan opposite over adjacent. Alright? So we see this is our opposite and this is our adjacent. So we can use the tan ratio to find the bearing from angle A to angle C. We're going to say tan theta is equal to our opposite would be 44 over our adjacent, which is our 33. Alright. And so we are going to say tan inverse, because we want to find what theta is. 44 over 33 is equal to theta. Alright, and now our tan inverse 44 over 33 would give us 53.14 is equal to theta. Right? We now found what the angle there would be equal to 53.14. Alright, so we need to see now. Alright, so start from our north to get to point C. What we would need to do is to add our 0.73 plus our 53.14. That will give us a bearing of 126.14. Right? What we're saying is that from our north as well, to get to C would be all of that distance. And it would be 126.14 degrees. Alright. So we found the angle in the triangle right there to be equal to 53.14 degree. Then now to get the bearing from A to C, we take that point from our north and go all the way down to C. So the bearing of C from A will be equal to 126 degrees by 1/4. We'll look now on our next question. And our next question says that the journey of a ship sailed from A, we draw our north line, and it traveled to B. Okay. And so it didn't give us that, but it said from A to B, so we know this would be at 270 degrees, right? So this would be a straight line, and it traveled for 32 kilometers. And go to point B now, and B starts from our north. To go to C, it traveled 40 kilometers, right? And this distance is 45 kilometers. So point C. Right. And so now the first part of the question asks us to find a distance AC. So we need to find this distance. Right? And what do we know? We know that if from A to B it traveled 270 and from B to C it traveled 40 degrees. We're going to make an assumption that this is a straight line, and so now we know the 40 degree, we're going to say this would be the 50 degrees. Alright? Because 40 and 50 would add up to be 90 degrees. Alright. See, now we know that now, and we're trying to find this missing distance. So what we can use is the cosine rule, which is if we know two distance and an angle between it, it is equal to b square equal to a square plus c square minus 2ac times cos b. Alright. So we are trying to find the distance AC. Alright, and we know that, let's call this our A. See, now this is an angle, opposite it would be our length. This is an angle C, the opposite it would be the length. So our B square is equal to A square is equal to 45 square plus our 32 square minus 2. A is 45 and our C is 32 times cos 50. Alright, so plugging this on our calculator, 45 square equal 2025. Plugging the square root of 32 square, we get 1024. 2 times 45 times 32 will give us 2880, and the cos 50 rounded up is 0.642. Alright, so in applying the cosine rule, we need to work this section. At most times we normally use a bracket. Alright, we need to do the addition first, then the multiplication, then we do the subtraction last. So b square is equal to 2025 plus 1024, that is equal to 3049, subtracted from 2,880 times the cos. That would give us a 1851.2. Alright, so we're going to do subtraction, then we're going to find the square on both sides. And so subtraction will be 1197.8. Then finding b, we need to square both sides. So b would be equal to the square root of 1197.8, and that gives us a 34.6, or we can run it off to 35. So this distance right here would be equal to 35 kilometers. And the second part of the question now asks us the bearing of port C from port A. Alright, and what do we know now? So we're trying to find the bearing, this angle right here, right? So from A, we're trying to find a bearing all the way to C. So we know this angle, we know this side. We want to find this angle, but we know that side. So we can apply the sine rule. What the sine rule says now is in finding an angle, it would be sine A over A, which is the distance, sine B, the angle, over B is equal to sine C over C. So in finding the angles, we put sine A at the top. In finding the distance, then we would put A over sine A. So we're trying to find the angle. Alright, we're going to use sine A over A is equal to sine B over B. Alright, so we don't know angle A, so we're going to say sine A, but we know the distance, which is 45, is equal to B, sine B. Sine B is 50 over the distance is 35. Alright. Now we have one unknown. We're going to then find the cross product, which is equal to sine A times 35 is equal to sine 50 times 45. Alright, in making sine A the subject, we need to divide through by 35. And so sine 50 times 45 divided by 35 will give us 0.9849. So sine A is equal to 0.9849. So in order to find what A, we need to say sine inverse 0.9849 is equal to A. We're plugging this in our calculator now. Our A is equal to 80 degrees. Alright? This angle right here is equal to 80 degrees. Alright? So now, in finding bearing of A to C, it would be 270 plus the 80, which is equal to 350 degrees. So the bearing of port C from A would be equal to bearing of C from A is equal to 350 degrees. Alright. And that is the second question in its entirety, in which we found the distance AC and the bearing of C from A. We're going to look on now our question, which asks us about the line segment. And the equation of a line, or the equation of a straight line, we know the general formula, which is y is equal to mx plus c. So we're saying now the equation of a straight line, y equal mx plus c. With that said now, the question gave us that it says passes through a point A. The point A, the line segment BC, right, passes through a point A. And the coordinates for A is negative 5, 3. And give us our gradient is equal to 2 over 5. So our gradient and those 2 points. So any line, if our point is, if it passes through a point, then we know we can use those coordinates to test the equation of the straight line. So we're saying y, see that our x, so this would be our x variable, this would be our y, so we can say y, which is equal to 3. Our m, which is our gradient, is equal to 2 over 5. Our x is equal to negative 5 plus c. We don't know what our c is, but we can then apply the point and the gradient to solve the equation. So 2 over 5 times negative 5, that would give us a negative 2 over 3 plus c. Alright, so we need to find our c, so we need to transpose this negative 2, and in transposing it, it will be 3 plus 2 is equal to c. 3 plus 2 is equal to 5, equal to c. So we need to put this back into the form, which is the equation of a straight line. So we're going to say y is equal to m, our gradient is 2 over 5, and x plus c, or c is equal to 5. So that is our equation of the straight line. Y is equal to mx plus c. Alright, now it asks us to see if a line is parallel, and that line is, so is parallel to BC. In testing that a line is parallel, we'll have to show that their gradients are the same. Right? So this line, it is a straight line, however, we're not seeing it in the correct form, which is y is equal mx plus c. See the y here, we don't know what our mx and our c is equal. We need to put it in the form. In order to do that, we'll have negative 5x. We're going to subtract our 2x from both sides. 1 minus 2x. It should be our y. Alright, in solving for y, to make y subject, we need to divide by a negative 5. We're dividing that on both sides. Right? And so this would cancel our y. Seeing that these two are negative and divided, we're going to try to put them at the front here. It's 2 over 5x. So the negative will cancel, but this side now, even though we have the negative 5 in the denominator, the entire fraction will be negative. So it's 1 over 5. And what we did was to put the negative 2x divided by negative 5 at the front. And we know that both those negative signs would then be positive. And so what we were able to see now, this is our gradient, which is 2 over 5. And this is our gradient, 2 over 5. And so because they are equal, these two lines are parallel. We see this equation is 2 over 5x plus 5. And we see this equation, 2 over 5x minus 1 over 5. However, due to the fact that their gradients are the same, then those two lines are parallel to BC. And that is that question. Alright, so the next part of the question now, it is the function in which we are given this function of x is equal to 2x minus 1 over x plus 3, and g of x is equal to 4x minus 5. We are first asked to find g of 3, right? So we're going to substitute when x is equal to 3 into the function. We'll say 4, 3 minus 5. 4, 3 is equal to 12 minus 5, and that is equal to 7. So g of 3 is equal to 7. That's a lovely 1 mark there. We're now asked to find f of g of 2. So in finding f of g of 2, and this right here is a composite function in which we have f on the outside and we're going to put g on the inside. That's an easy way to look at it. So we're just going to write back our f function, 2x minus 1 over x plus 3. And what this means now is that we're going to substitute the g function, which is 4x minus 1, into the f function. F of g of 2 is equal to, wherever we see x, we're going to substitute our g function. So it's 4x minus 5, that would be our g, minus 1 over our x, for x minus 5 plus 3. Alright, so we are just going to substitute it, then we're going to find the value when it is equal to 2. So let's try to bring this over a little bit more. 2 times 4x, we know would get 8x. 2 times negative 5 would get 10 minus 1 over, we don't have anything to really affect the bracket or the number that we just substituted, so it's 4x. Minus 5 plus 3 was a minus 2. Alright, I guess we can do some tidying up right here. 8x minus 11 over 4x minus 2 is our f of g of 2. So now we're going to substitute our x to be equal to 2. So we'll have 8, 2 minus 11 over 4, 2 minus 2. Alright, what we'll have here is 8 2s is 16 minus 11 over 4 2s is 8 minus 2. What this is equal to? Is equal to a 6 over 5. So f of g of 2 is equal to 6 over 5. Alright, so the next part of the question now asks us to find the inverse of f. Alright, so we're going to find f inverse. Alright, so given our function f, first step we're to do is to define it with respect to y. So we're saying y is equal to 2x minus 1 over x plus 3. That's the first step, right? To define a function with respect to y. The next step now is to interchange the y for our x and our x for our y. So our y will become our x and our x will become our y. 2y minus 1 over y plus 3. Alright, so that we now interchange our x variables for our y and our y variables for our x. As you see now we have a y plus 3 in the denominator. We need to try to get rid of that. We're going to multiply both sides by y plus 3. Multiply y plus 3. Put in a bracket to be safe. So we'll have x times y plus 3 is equal to, this would cancel, equal to y minus 1. So x times y gives us xy, x times 3 gives us a 3x equal to y minus 1. Alright, so now we have a linear, we have it in a linear form. What we need to do now is to group. In order to group now, take over this y on this side and this x on this side. We'll have xy minus 2y is equal to minus 3x minus 1. Right? We have to remove the 3x, it will become a minus on that side. Thinking about this positive 2y will become a minus. So the next step now, see now we have y in these two terms. We need to factor out a y. So y into that. Y into xy goes x. Y into 2y goes minus 2 equal to minus 3x minus 1. Alright, what we need to do now is to make y the subject. We need to divide through by x minus 2, x minus 2. This would cancel. We would have y is equal to minus 3x minus 1 over x minus 2. In wrapping up now, we need to define the function back. So what we were finding was the f inverse of x. And what we're saying is it is equal to minus 3x minus 1 over x minus 2. Alright? And this would be the inverse of x. And this would be f of x. Alright, so we're able to answer all the questions. First, we solved the bearings question with the plane, then the ship from port A to port B to port C. We then looked on the line question in which we expressed the equation of the straight line and test if the lines were parallel. For this question, we then found g of x when x was equal to 3. We then found the composite function f of g of 2, and for this part here we're finding inverse. So thank you for joining us. Hope you can join us on our future videos, and hope this video was impacting in some way.